Good morning, class 8. How are you? I hope everyone is staying back home. We all have to stay back home to fight this health crisis, as I told you earlier. Now, we are meeting after one day gap. You can remember in the last video, we were discussing about postulates of kinetic theory, and in which I told you about these points, and we were on the verge of writing the fifth point. Unfortunately, the video got disconnected. Now let's move on. Let me just quickly finish it off. The average kinetic energy of the particles is directly proportional to its temperature. The idea is simple, as I told you. It's just that when we provide heat energy, the temperature of the substance starts to increase. Okay? And if we are converting the substance from its solid state to liquid state, as we were discussing in the last video, its kinetic energy also increases. So it increases with temperature. So it is directly proportional. Now, how do we write it in physics terms? Because I think in this class, this is the first time you will be dealing with this. So this is the way we write. This is a symbol of directly proportional. Now, what does it mean? That if we double the temperature, the kinetic energy would also get doubled. So it is directly proportional in this way. Okay? So these are the 5 postulates that we have for kinetic energy. Now, as you know, that the particles of different and so on. So I won't be drawing all of it. And in liquid, there are less space. However, in gases, the space is huge. So this is the way the intermolecular space is. Okay, so moving on, in this class also we will study about and we will compare the characteristics or properties of the 3 states of matter, which are solid, liquid and gas. Okay? However, with a difference. Since 6th and 7th, I know that you have already been going through these characteristic properties. But now we want to understand, and now we want to make sure that these properties are well understood. And we know the exact reason for that as well. So if I tell you one property, why a solid behaves like this, you should be able to give me an answer. Okay? So for example, if I give you a question that why solids have fixed shape and volume, why they are hard or rigid, why they are less compressible. So we should know the answer, the exact answer. Alright, so let's have a look at this table. So what we have is these are the characteristic properties. We can have a couple of them more as well. The first one that we have is in terms of intermolecular distance, then we have intermolecular force, then we have nature, which describes how hard or rigid is the state of matter. Then shape and volume, then we have density, which is mass divided by volume. Density is basically how closely the molecules are to each other. If they are very close, then the density is high, and if they are far away from each other, then the density is less. Kinetic energy, how fast or slow are the particles of the substance moving. So that is kinetic energy. Movement of particles, it is just the movement. It is very closely linked to kinetic energy. Then by mistake I have written kinetic energy twice. Then we have diffusion, and the last one in this chart is compressibility. I'll take up one or two more properties as well as we go. Now for solids, as we have already discussed, so I'll be going through these properties, which most of the properties you already know, but I'll be giving you the reason here. Okay. Now we know that intermolecular distance in solid is very small. Either it's negligible, very small, or we call it least in solids. In liquids, it is less, but it is more than solids, and it is maximum in gases. Intermolecular force, maximum, and in case of liquid, it is less than solids, and in gases, the intermolecular force are the minimum. I told you that they are inversely proportional to each other. One goes up, the other goes down. Now, remember, these two were in the postulates of kinetic theory. Okay? So, based on these two postulates, we have the different nature which is shown by the matter. Remember, these postulates were meant to help us to study the behavior of matter. That is what kinetic theory is all about. Now, let's start with this nature. They are very hard and rigid, as we see this duster here, made of wood on that side. It is very hard and it is rigid. Liquids, they can flow slightly. That means they are not that hard or rigid. And as far as the gases are concerned, they are very fluid. They are not hard at all. Okay. Now, let me just quickly write an explanation to it. Because intermolecular force keep the particles together. This is just one sentence that I have written, and I'll write another one, and we will see how we can use this sentence for explaining various properties. Because intermolecular force is less than solids, so liquid particles can move to short distance. And the last sentence is because intermolecular force is almost negligible, nil, so the particles Now, let's see. Okay, let's start with this nature. Why solids are hard and rigid? Because intermolecular forces in solids, you may write in solids, keep the particles together. So they are very closely packed, and that is why they are hard and rigid. Now, why solids have fixed shape as well as fixed volume? Because intermolecular forces in solids keep the particles together. And that is how they have fixed shape and volume. Density. Why solids show maximum density? Because intermolecular forces in solids keep the particles together. So they have maximum density. While the kinetic energy in solids is least, minimum, because intermolecular force in solids keep the particles together. So the particles are not able to move freely. Movement of particles, again same. Then we have diffusion. Diffusion is, let's understand this concept. It is the intermixing of two different particles, different types of particles, without any chemical reaction. Let's see. For instance, if we use spray here, the particles of that perfume spray, because there is a lot of space available in air molecules, between the air molecules, the particles of perfume spray would mix and would take up those empty spaces and would mix and would diffuse into this whole room. For instance, if we have a cold food in front of us, do you think it would smell? Would we be able to smell cold food? No, we would not be. But if we heat that food and it becomes a little hot, then the smell, the perfume, the scent of food gets into our nose. That is diffusion. Another definition, like for instance we have water. We simply put some salt in it and we don't stir it. Don't use any spoon. After some time you would automatically notice that the salt particles would become of very small size, indicating that some of the salt or most of it has already been dissolved in it. We didn't do anything. There's no chemical reaction to it. Are you getting the point? These are the examples of diffusion. So solids, it is least, they don't diffuse. However, liquids, their diffusion rate is more than solid. However, when it comes to gases, gases diffuse the most. Okay? Alright. So we can explain with a little bit shift in this statement, and you can answer most of the characteristic properties based on it. And the last one we have is compressibility. We know that solids cannot be compressed. It is because there is no intermolecular space available between the molecules. There is no space between the molecules. How can the molecule be compressed then? However, when it comes to gases, we can always, if we compress this molecule molecule has all the space available. It can be compressed very easily. However, when it comes to liquid, they can be compressed a little bit. Okay? So automatically when we say that the compressibility of solid is almost nil or it is least and the compressibility of gases is maximum, that automatically means that for case of liquid it is in between. Alright. Now next thing we would like to discuss a small topic which is change of matter, change of state of matter. We have already introduced this concept. We have already discussed this concept in the last lecture as well. Change of state of matter. Like discussed, if we have ice which is in solid, we heat it and then it becomes water in liquid form. And steam, that is gaseous form. Now we need to remember that again the kinetic energy of water in liquid is more than solid, and in steam the kinetic energy, heat energy, is more than water in liquid form. Okay. Now we also know if we want to convert water in liquid form back to ice, what shall we do? We have to cool it. We have to cool it. So it means in chemistry or in general as well, we say that this reaction is reversible. We can go back to the original state by using heat energy. And that is exactly the reason why we keep water in our refrigerators. And what is the job of refrigerator? Refrigerator would absorb extra heat energy and would throw that heat energy out. That is why if you could notice at the back of the refrigerator, it's pretty hot. Where does that heat comes from? The heat is that heat which has been absorbed by the refrigerator or the freezer from the things which are kept inside the refrigerator. So losing heat, it goes back to solid. Similarly, water vapor, as we know, on evaporation, the water converts into water vapor, rises up. On the way to formation of clouds, they slowly lose heat energy, they cool down, and the water condenses to form. That water vapor converts into liquid state and precipitates down in the form of rain or snow or other forms. So again, by providing heat, we can convert water liquid form into steam, and by taking heat from steam, if it loses heat, we can convert it back to water in liquid form. Okay? So with that, please keep that in mind. And with that, I end the lecture for today. I hope you would go through these characteristic properties because I'll be putting in some questions in the assignment based on that, and you should be in a position to answer it correctly. I just want to request you that please take this timetable which has been made specially designed for you by our principal sir. He has put in a great effort, keeping in mind that your studies should not be affected. So please do watch the videos. If you have any questions, please get back to us. Even in the video, there is an option of, at the end of the video, you can put in your comments in case you have any question, whether you like the video, put in the sign. You can always subscribe to the video so that the next time the video reaches to your phone very quickly. Because it has been also noticed that some of you are not able to access or not accessing our school smart app. So please do so that make the best use of it. We have time on us. We are at home. So please make the most of it. It's an humble request. And I will see you soon. Take care, stay back home and study well. Alright.